So matrix multiplication part 2 is what we're doing today. So it's the last part of your notes if you're in class. All right, so your do now was to lead us to this, verifying there's a matrix product and finding the dimensions. And that's because I call it the smile check. If you're multiplying two matrices together, the number of columns in the first matrix and the number of rows in the second matrix have to be the same. They have to be friends. It has to be a happy situation. And the product is going to be the number of rows from the first column and the number of, from the first matrix and the number of columns from the second matrix. So for example, if we go back to our do now, where we had a 2 by 1 multiplied by 1 by 2, notice how the number of columns in the first one matches the number of rows in the second matrix. They're smiling at each other. What's left will be the dimensions of their product. So my product would be a 2 by 2. Okay? And so that's how you verify if there is a matrix product and find the dimensions of it. Okay? So looking at this one, so here, the first thing you're gonna do is identify the dimensions of matrices A and B. Well, the dimensions here, we have a 3 by 2, and the dimensions here is a 2 by 4. And you want to verify that the number of columns in A equals the number of rows in B. So the number of columns in A is 2, and the number of rows in B is 2, and they are equal to each other. And so then you're going to write the new dimensions, and the new dimensions are the rows from A and the columns from B. So your product matrix would be a 3 by 4. Okay? Questions about verifying if there's a product? Exactly. The columns of A have to equal the rows in B. All right. So let's do an example together. So does either product AB or BA exist? So for AB, again, I'm analyzing the dimensions. So the dimensions here is a 3 by 2. The dimensions here is a 2 by 4. If I'm multiplying A times B, that means I have 3 by 2 times 2 by 4. Can I multiply a 3 by 2 times a 2 by 4? Why, yes, I can. They're smiling at me. And the dimensions of the product is going to be a 3 by 4. Okay, we're going to go ahead and actually find this product so that you can see that it looks like a 3 by 4. All right, remember when we talked about multiplying, you are multiplying the elements in the row times the elements in the column and then adding their products together. So for our A equals B, we know that we're making a 3 by 4. So my first element comes from -2 times -1 plus 1 times 2. That's my first element. My second element is going to come from -2 times 0 plus 1 times 0. So I have negative 2 times 0 plus 1 times 0. You just go down the column. Row, column, row, column, row, column. And we're just going to keep going. So I have negative 2 times 2 plus 1 times 0. I completed that column. And then I have negative 2 times 1 plus 1 times 3. Okay, once you've done the first row, the rows, the numbers to the left is changing, but the numbers to the right are going to stay the same. So once you've done that, you're just following a pattern. So the values in the second row are 3 and negative 2. So they're replacing negative 2 and 1. So it becomes 3 times negative 1 plus negative 2 times 2. 3 times 0 plus negative 2 times 0. 3 times 2 plus negative 2 times 0. 3 times 1 plus negative 2 times 3. So that second row is complete. I'm going to go to the third row. And this time I'm replacing the 3 and negative 2 with zeros and ones. So 0, negative 1 plus 1, positive 2. 0, 0 plus 1, 0. 0, 2 plus 1, 0. 0, 1 plus 1, 3. Did I produce a 3 by 4? I did. And that's why the dimensions are 3 by 4. So AB equals negative 2 times negative 1 is 2, plus 2 is 4. 0 plus 0 is negative 4 plus 0 is negative 2 plus 3 is 1. Negative 3 plus negative 4 is 0 plus 0 is 6 plus 0, 3 plus negative 6, 0 plus 2, 0 plus 0, 0 plus 0, and 0 plus 3. And that would be your product, which is a 3 by 4, as you say it would be. So following what we did up top, if we were to check B times A, what are the dimensions of B? 2 by 4. What are the dimensions of A? 3 by 2. Are the number of columns and the number of rows equal? No, sad day, womp, womp, womp. So this means that it's undefined. When that doesn't happen, it is undefined. Okay, so from looking at A times B, do you see the importance of doing row 1 correctly? Because row 1 sets the pattern for the rest of the matrix. All right. So on the you do, I don't want you to multiply. I just want you to tell me if it's defined or undefined? And if it's defined, what are the dimensions going to be? You don't actually do it, just is it defined or undefined? And what are the dimensions if it's defined? Okay, so the first thing you would do is say what the dimensions are. So A is a 2 by 2, B is a 1 by 2. So there's 2 columns. And C is a 2 by 3. Okay, so if I want to multiply A times B, is that undefined or defined? Huh? 2 by 2 times 1 by 2? It is undefined. AC is defined, and it would make a 2 by 3. What about B times A? It will be defined, and it would produce a 1 by 2. Good job. What did you get for C times A? Undefined. And what did you get for B times C? Perfect, defined. It's a 1 by 3. And what did you get for C times B? Undefined. Okay, how do we feel? Doable? Okay, the order matters when you're stating whether it's defined or undefined. Okay, remember if you're checking, so that if you still have to write them side by side and do the smile check, that is okay. So if I have a 2 by 2 times a 2 by 3, they're smiling. So they produce a 2 by 3. Okay, so if you need to do the smile check, do the smile check. All right. Last part of our notes is word problems. Yay! I know you're so excited. So in 1996, Washington and New York Giants played the highest scoring game in National Football League history. The table summarizes the scoring. A touchdown is worth 6 points. A field goal is worth 3 points. A safety is worth 2 points. And a point after touchdown is worth 1 point. Using matrix multiplication, what was the final score? Okay. So we're going to take this and apply matrix multiplication. So the first thing we're going to create is our matrix S, which is our score. And so when we produce, well, we're trying to find the total of S. So S equals our, what can we call this? Our what? Our points? Points, right? It's going to be our points times the value of the points, right? So how many points they got times what the value of the points are. And that's going to tell us our score. Well, our points, making that into a matrix, would be a 10, 1, 0, 9, 6, 0, 0, 5. That's my points matrix. My value matrix, in order for this to be multiplied, what would the dimensions, or how many rows would need to be in my value matrix in order for me to multiply? It would have to be 4. And so I have 4 values, and I'm just going to write them vertically to make 4. So a touchdown is 6. A field goal is 3. A safety is 2. And a point after touchdown is 1. So I have a 2 by 4 times a 4 by 1, which means that it will produce a value. So 2 by 4 and a 4 by 1. what are going to be the dimensions of my scoreboard? A 2x1, which makes sense, right? Because in a game, how many scores are there? 2. Okay? And so now we're going to proceed to multiply. So we're going to take the elements in the first row and multiply each one by the column. So we have 10 times 6 plus 1 times 3 plus 0 times 2 plus 9 times 1. That's my first row. I'm going to do what I did to the first row to the second row. So it's going to be 6 times 6 plus 0 times 3 plus 0 times 2 plus 5 times 1. So what was the final score? Well, what's 10 times 6? 60. What's 60 plus 3? 63 plus 0 is 63. Plus 9 is 72, right? I don't know, I wrote it so tiny. All right, let's do the next one. 6 times 6. 36 plus 0 is still 36. 36 plus 5 is 41. So the final score was 72 to 41. Okay, so you unknowingly use matrices all the time. This is just showing you what you're doing. Was it terrible? No, it's not at all. Okay, here is your last practice problem. So there are 3 ways to score in a basketball game: 3-point field goals, 2-point field goals, and 1-point free throws. In 1994, suppose a high school player scored 36 2-point field goals, 28 free throws. And 2006, suppose a high school player scored 7 3-point field goals, 21 2-point field goals, and 18 free throws. Using matrix multiplication, how many points did each player score? So I'm going to pause and let you see where you can get in 3 minutes. Okay, so your first matrix would be the players, right? So your players matrix would be made up of player 1 had 0 threes, 36 twos, 28 free throws. Player 2 had 7 threes, 21 twos, and 18 free throws. So players. And then the value of these are 3, 2, and 1. How are we doing so far? Awesome. And now we proceed. So we have 0 times 3 plus 36 times 2 plus 28 times 1. It's player 1. Player 2, we have 7 times 3 plus 21 times 2 plus 18 times 1. And we proceed to add. So we have 0 plus 72 plus 28. That gives us 100, right? Then we have 21 plus 42 gives us 63. And then plus 18 gives us 81. So player 1 The player in 1994 had 100, and the player in 2006 had 81. Does seeing it in the format of a word problem kind of help with the pattern? All right, well, that is all I have. If you have any questions,